Hey there, in this video, I want to quickly go over uh, how we would run an item analysis with Likert type data. So if we had survey data or we had another type of response data that were more ordinal categories instead of using right and wrong. So I'm going to do that with our SPSS anxiety questionnaire data set. Um, and we can do this really easy in R. I'm going to use the item analysis package. I like it better for Likert type data than the CTT package. Because it just has a special function specifically for Likert data or Polytomous type items, which are ordered categorical type data. So we're going to open our item analysis, load it into R. If you haven't installed the package before, click on packages and install, and you can install it here. I'm going to load the SPSS anxiety questionnaire data. I'm going to use the read file function from the SAQ tools package to load it. It loads SPSS data files. Here I just give it the file path to where it's saved on my computer. And I'm going to store that file in an object I'm calling SAQ. We'll run it. You'll see it's popped up here in my environment section. You know, there's 2,571 observations and 23 variables. We can print out the first 6 rows of the data frame to the console here. So we can see, person 1 said disagree to question 1 and strongly disagree to question 2. To run the item analysis report, it's pretty easy. We'll use the item analysis 2 function out of the item analysis package. You can put your cursor inside there and push F1 on your computer and get the help function to come up for this function. And you can see all we really need to give it is our data and what the response options are. So that's what I did here. My data set, I stored an object called SAQ. So I put that in there, and then we see the response options range from 1, 2, 3, 4, and 5. So I'm going to run the item analysis function and store it in an object I'm calling report here. And this one automatically prints to the console. So we'll scroll up to the top. We get some information from the author of the package, and then we get our item statistics here. So the first question has a mean score of 2.3. So remember, this is our difficulty parameter, or we might call it the location parameter or the endorsement parameter or something in because there's not really a right wrong answer on here. Remember, this survey was supposed to try to assess anxiety with using computers or using statistics or using SPSS. We'll try to flush that out a little bit more when we get to the EFA module, but we're trying to measure anxiety in a sense. And so our main score here is that difficulty parameter. So it's how the average location on that anxiety continuum. You kind of think of it like that. And remember, ours ranges, we said, from 1 to 5 here. The item difficulty, what they're trying to do here is place this mean score back on like kind of the original item difficulty 0 to 1 type metric. All this is we're taking the mean score here and dividing it by the total score, the maximum possible score, sorry. So like here we had 2.347, divide that by 5, and we get 4.75, 4.748. That's all this number is. So you can kind of interpret it more similar to how we interpreted the difficulty parameters in in the traditional item analysis module. I wouldn't say that 47.5% of people got this item correct. It's more so it's more the proportion of people who used all of the available points, kind of in a sense. We have two discrimination coefficients here. Again, the point by serial and the what they're calling the polyserial. So this is just a straight Pearson's R correlation between our first item and the total score. And this one is the same thing, except for we're assuming a normally distributed latent variable underlies the item test set. And kind of the idea is here is that these polyserial correlations should be more stable across samples than these point by serial correlations are. But we're still looking for the discrimination parameters to be positive in the sense, right? Because that means in this case, people with greater anxiety are more likely to endorse higher values on this item. And that's what, if the total score is supposed to represent a measure of anxiety, and higher scores on the total scores mean more, that you're more anxious, then a positive correlation would indicate that people who rate item 1 positively also have high anxiety. And that's what we would want to see here. We'd want to see kind of a strong correlation between the item and the total score. So we interpret the discrimination parameter same way we did in the other analysis. Check out what's going on with item 3 here. Oh, my highlighter work. Look at these discrimination parameters. They're pretty strong and negative. So this is alerting you to say, hey, something's going on here. What's happening? If we look back at our SPSS anxiety questionnaire, look at like the first question, statistics make me cry. If you're more likely to endorse it, say strongly agree, that's probably more of an indication of having some type of anxiety. But question 3 is standard deviations excite me. Strongly agree is probably an indication that you aren't as anxious about studying statistics or any kind of having some more math anxiety. So question 3 is what we would call like reverse coded. It's stated differently than all the other questions on the survey. So this one, lower values on this question probably indicate more anxiety. So this might be an instance where one, we either expect to have this negative discrimination parameter, or we need to reverse code that item where instead of 1 equals strongly disagree, we'd have 5 equals strongly disagree, 4 equals disagree. So we just reverse the 1, 2, 3, 4, 5 codings. So you could go through this and do the same type of interpretation we did the last time. You could have kind of this, you can kind of think of these next ones as like a distractor analysis type assessment. Here we just get the proportion who chose each one of the categories. Around 10% of respondents chose strongly disagree to item 1. Around 52% of participants, so over half, chose disagree to item 1, and a little more than 1.5% chose strongly agree to item 1. You can see item 2, around 56% chose was that strongly disagree to item 1. So we could go in here and see, are there any response options that aren't being used? One thing is we have very few responses in this upper category. Maybe that's a suggestion that, hey, nobody's utilizing that end of this spectrum. Maybe it's the response options are maybe too wide here. These point by serial correlations and polyserial correlations, these are the distractor analysis discrimination parameters again. So if each item is supposed to represent some type of continuum from low anxiety to high anxiety, we might want to see like the distractors going from like negative correlations to more strongly negative correlations to more strongly positive correlations, kind of like what we see in item one here. You know, lower core, this correlation here would say that the correlation between those who select strongly disagree on item one and then the total score on all the other items is negative. Well, that's probably what we want to see, because if you're low on the total score of the other items, you probably have lower anxiety, and you're probably selecting at the lower end of this item. So it's working well to contribute to how we're measuring the total score. Look at item three. It's working that same way, but in reverse, right? Because remember, this one was one that should be probably reverse coded. And so we could go through here and kind of do sort of the same thing. Look at what's going on with item two here. Some weird stuff happening here. We have a positive correlation if you're saying it's strongly disagree. It's kind of weak though. It's kind of weak correlations throughout each one too. But we're kind of seeing this general pattern. But in this one, we're like over half of people were picking the first response option. So this might be an indication of the quality actually of item two may actually be kind of poor. So this is the way that we can use item analysis as kind of a first step to look at how well our items are actually functioning and kind of the quality of the items before we move on to more advanced kind of analysis. So anyways, I hope that was help how you can use item analysis for Polytomous type, like Likert scale type data. As always, if you have any questions, please feel free to reach out and let me know. Thank you.